Hey guys, welcome back. Let's have a look at this question. So, if you look at this, this is again from indefinite integration. And if you have done partial fractions, then this is one of the forms. Now, the condition for partial fractions is that degree of numerator expression, which is x to the power 1, should be less than degree of denominator, which is 2 and 2. If you expand this, you will get 4. So, 1 is less than 4. Hence, you can apply partial fractions. Which form is this? This is the third form where the roots are complex. When we say complex, if you put x square plus 1 equals to 0, you get x square equals to minus 1, and you get an under root over a negative value, which is a complex root. So this is the identification. What we do here is first we change this. We do not integrate. What we do is we change this integration expression to another form. How do we do it? Because we have complex roots, the form for this is a x plus b. So you start with the first alphabet a and b, use it, and then divide it by this same complex root. Plus, you have another complex root, so you will now write cx plus d divided by x square plus 3. So remember, this is the form. If you're using a and b, once you're done with b, you will go to c and d. And then if you have one more, you will go to ex and f, and so on. Okay, after this, what do? Normal mathematics, you have two fractions added. So you take LCM on the right hand side. So when you take LCM, you will get AX plus B. Remember, put a bracket, else you will make a mistake. Plus CX plus D, bracket x square plus 1. Copy the left hand side as it is, no changes. Remember, this is again a 2 mark question, so it will not take much time. It just looks little lengthy. Now, once you cancel this, there is no linear root over here. When I say linear, there is no x minus 1 or x minus 2 ka whole square. This is called linear roots. If you have linear roots, you can substitute it directly in place of x and get one of these values. In this case, there's nothing to substitute, so the only option is comparing both sides. That is, we'll compare the coefficients. For that to happen, we first need to expand them and keep the like terms together. For example, let's expand this. Let me bring it to the left hand side. So ax times x square becomes ax cube, plus you will get 3ax plus bx square plus 3b. So we're done with these two brackets. Moving on to the next one. Plus cx cube plus cx plus dx square and plus d. Now, what are the like terms? If you look at this, you have two cube terms over here. Then we have one x term here and one x term here. Then we have an x square term here and one x square term here. And then you have your constants. So 3b and d is a constant. So let's write them together so that we do not make any silly errors. So take x cube together, you'll get a plus c x cube. Take x square term together, so you will get bx square and dx square, so you will get b plus d bracket x square, plus take the x terms together now, so 3a plus c x, and the last is 3b plus d. Okay, so 3b plus d is constants. X term is here, so 3a plus c, x common, then bx square term and dx square term is here, then ex cube and cx cube is here. Now, if you look at the left hand side, what do you mean by equality? That LHS is equals to RHS. Meaning, if you do not have an x cube term over here, we can write 0 x cube. We can, because 0 into anything is 0. So you will here write comparing coefficients. You can skip some steps in the exam, but since I'm explaining you, I'm writing everything on both sides. So let's compare. So x cube, there is no x cube on the left hand terms, meaning 0 x cube can be written. or assumed. So A plus C becomes 0, which implies A is equals to minus C. It's one of the equations. Similarly, look at B and D. You have B plus D again equals to 0 because there is no x square term. So you can assume 0x square as one of the terms on the left hand side. So B plus D is 0. Again, B equals to minus D. It means you find any two values, let it be A or B, and you get the other two directly. Now look at this. 3A plus C is equals to 2 because the coefficient of x is 2 on this side. So you will get third equation as 3A plus C equals 2. Now use this. A is equals to how much? Minus C. So put it over here. We will get 3 bracket minus C plus C equals 2. Or how much? Minus 3C plus C equals minus 2C. So minus 2C equals 2 or C equals minus 1. So if C is minus 1, A is 1. Okay. Moving on to, let's find 3B plus D. So 3B plus D equals, again, there is no constant term on the left hand side, so it will become 0. Let's use the value of B from here. So B is how much? Minus D, substitute it. So 3 bracket minus D plus D equals 0. Technically, you will get a 0 because there's nothing over here. So just to complete this, minus 3D plus D becomes minus 2D equals 0 or D is 0. So if D is 0, B is also 0. This is your goal in partial fraction. You need all the values of A, B, C, and D, whatever your constants have been taken in the question. Once this is done, we will take all these values, put it back in this expression, and put this entire expression, replace it with this, and place it over here. Okay, so let's see. Integral u we had this expression as this. So A ka value is how much? 1. B is 0. So basically it is x upon x square plus 1. So x upon x square plus 1. Okay, put a big bracket. Then you have plus. The value of C is how much? Minus 1. Okay, D is 0. So this will become minus x upon x square plus 3. So minus x upon x square plus 3 dx. This is what we do to break a partial fraction into separate terms so that we can apply other integration techniques. Okay, now what do we do after this? It's easy. Take this as t and you will get this term. Okay, so let's see. So let x square plus 1 as t. If you do that, you will get 2x dx is equals to dt. We just need x dx on the left hand side, so dt by 2. If you look at it, this is x dx upon x square plus 1. So if you rewrite this, you will get, first of all, integral of dt by 2. Okay, remember I'm not expanding this, but I can mention a dx here and a dx here. Let's do that for simplicity so that it makes more sense. Put a dx here, put a dx here. That's it. So x dx is how much? Dt by 2. So write half outside, dt here. And what was this? This is t. So write a t over here. Done. Same thing with this. Instead of 1, you will have a 3. We are not doing it because you will get the same expression back. So you are straight away going to write minus 1 upon 2 again. Integral dt upon t. It will be exact same expression. The only difference is I am going to call this as a u so that we avoid any confusion. Let's take this to be u. If you guys are good or fast at differentiation, you will not need this step, but we will still go ahead and do it for everyone. Du by 2. So let's call it u, not t. This will become du upon u. Okay, this was u, replace here, and that's it. Now you can see a direct formula. So this will now become half ln mod t. Okay, what is ln? Ln is nothing but log with a base e. In calculus, the base of the log is always e, minus half ln u plus c. Okay, now it's not done yet. You have to replace the value of t here and replace the value of u here. So let's do that. And we can also take half common, ln mod x square plus 1 minus ln x square plus 3 bracket closed plus c. Is this the answer? Yes, but remember, log A minus log B का formula is log A upon B. So if you know this, write it. It creates a good impression when you write the answers. So your silly mistakes sometimes can be avoided by the teacher correcting it. Okay, it works. Plus C. And that's it. This is our answer. Let me use a light color. Okay, cool.